Hello, everybody. I'm going to go ahead. Is that better? Sound check? Looks good in the back. More? A little bit more? A little bit more? Good. You're good. All right. We are starting a little bit late. We have to end on time. And I think I will have time for questions. But I think I'm going to ask you to hold your questions and not do this as interactively. If something really makes you mad, then just jump up, and that's okay. I'll respond. I think this is going to be a fun talk because there's a lot of edge infrastructure pieces. Today at the Open Infrastructure Summit, it's a major topic. And so this maybe will help frame the conversations going forward and what we're doing. Because edge is really about integration and automation. And part of the purpose of this cloud is to talk about it. It's like cloud, but also different. Because we're not just trying to take cloud infrastructure and make it into edge. We're trying to do something different. And the reason it's different, without trying to define edge for you, is that it's physically distributed, logically restricted, and networking limited. It's a different environment than the way we've designed clouds. And so I want to give you some introduction and background. This was supposed to be a two-person presentation. If you were hoping to bask in Mark's glory, he was not able to attend. He had a family emergency come up, and he is safely home dealing with that. And he is an amazing person to listen to. He's really involved and engaged in a number of topics. He runs a podcast called Infinity Paradigm and Beyond, which I find very interesting. A lot of the topics that we're going to talk about today come out of his experience from that podcasting and his notes here. And I keep getting my mouse in there, so maybe I'll try not to. And he's a director of engineering at Ericsson and focused on edge computing. And he also is an IDCA on the technical committee. So they're actually trying to do process, data center automation's process. And my background is similar. I'm the CEO and co-founder of a company called RackN, which is focused on physical layer automation around a project called Digital Rebar, so open source bare metal provisioning. And that's its own separate topic, which is not this one. And I co-host with Steven Spector the latest shiny podcast, where we actually are, I think, the only podcast that is focused very exclusively or very intently on edge topics. And so we talk to people all the time, all over the world, about edge infrastructure and what they're building and why they're building it and how they're building it. And so these are topics, everything that we're going to discuss are things that we've been fleshing out as issues on the show. This is an open invitation. Find Stephen or I if you have an idea or a topic or something you want to rant about. We love doing the Rantcast. We would love to have you on the show. So find Stephen or I afterwards and we'll talk about it. And what we do, our interest, Mark and my interest in data center automation and making data centers better places to run your business is a very important thing, right? It's really why we're all here. And so I want to talk through that. First, I want to give you a little bit of a framing. This is about edge infrastructure. It's not about edge applications, because we feel that first, you must understand that edge is a different environment, right? What we're talking about is thousands of sites, thousands of data centers, if you want to think about it. Current data center operations tools are really built around tens of sites. Now, we're not talking servers. We're talking about sites. Each one of these boxes would represent a fully autonomous site with its own provisioning infrastructure, with its own networking, with its own load balancers, with its own firewalls and perimeters and things like that. And that's usually how we think about building these tools. Just to give you a sense of scale, this is 100 sites, right? Pretty logical. And this is 1,000 sites. This is not a human scale problem to solve. You can't just write an Ansible playbook and then run it 1,000 times from your laptop. It's not going to work like that, right? So when we talk about needing to fix day 2 operations, We're not talking about fixing it so that I can run an Ansible play run and everything will work out correctly. We're talking about actually building sites that can fix themselves, because you can't manage 1,000 sites. It's a very different scale problem. And so when we look at what we're talking about edge, we have to say edge is not just cloud. We can't just scale down our platforms to fit into small systems, because they weren't designed for that management problem. Nor can we scale up our management tools and just say, oh, I'm going to just write a batch script that instead of n equals 10, it's n equals 1,000 and hope it works. Because it doesn't. That's not how it works. We have to be able to scale in our platforms and scale out our management. So we have to start thinking differently. So that's our warm-up. And there's a lot of questions. This talk is not about answering questions. It's not about the answers, it's about the questions. And what we really want to be doing is putting you in the frame of mind for how you're going to think about this problem, right? Not walk into sessions and say, oh, I'm just going to take something that we have that works in OpenStack and shrink it down with the shrink ray and hope that it works at the quantum scale. It's not like that. You have to think about things differently because you have to deal with management and things like that. And so there's a long list of questions. I'm certainly not going to read it. It's not my goal here. What I want to do here is frame up some of these questions, but also emphasize this, that finding solutions is really urgent. We have things in place. We're going to talk about it. And also thinking that we're going to find a single right answer is not the right headspace. Right? And this is one of the challenges to me with the open infrastructure rebranding. It's the same problem. I'm actually on the board of an Linux Foundation group for Edge also, LF Edge, where they're trying to solve these problems also. And they're coping with the same issue. There's a lot of different vendors, right? Hardware, operating system, platform, network, switch, right? You have all these different pieces. You have all these different components. You have all these different things that have to get done. We're not going to come out with a single right answer, right? There is not a single open source project that is going to solve these problems all correctly, or at least not now. Even something like Kubernetes, which is gaining a degree of ubiquity that is really impressive, is not ready to solve all these problems. It might not be the right solution for all these problems, right? It might not, in the end, actually be the right thing, because the way we have to solve problems with it are different. So we can't look for a single right answer. And one of the reasons why, to me, it's very important, if I can navigate my slides, is because there is a gorilla in the room in the form of AWS. They are not waiting for a committee to decide which open source project is the right way to automate an edge data center. Now, I know as individual companies, we have to make decisions, we have to do standards, we have to be able to say this works for me or this doesn't work for me. But it makes me very nervous when I watch us say we are starting a committee to begin working on an idea that we think might solve this problem, and it's going to go through an architectural review. I think that we have to do those things. I'm not arguing against those processes. But we have to be looking at what the marketplace is going to do. And the big vendors, AWS specifically, is not waiting for a design committee to give thumbs up on this stuff. They're building. That's what they do. That's how they move fast. And it's how they've become such a fierce competitor for this. And we have to keep that in mind as we think about what's going on at the edge and what the edge environment looks like. I've really missed Mark. Mark and I have. This is not a, Mark and I don't agree on every topic on this slide, and so you're missing the dynamics of the conversation. I'm going to try and give you a back and forth. Of the things that we agree with, though, this is a big one. Right? We are worried about what a marketplace looks like where there is only one hyperscale provider. So, and this is a really important point to think about when we think about why it's important to worry about what's going on. Edge is not new. It's not greenfield. right? My experience is very clear. There is no such thing as a greenfield data center, right? Or if there are, they're incredibly rare. When you walk into any infrastructure, you're dealing with the naming conventions, IP schemes, security restrictions, the preferences of those people, the hardware that they've decided to buy. You have to deal with what is in place. And when you think about edge, while I know everybody's excited about 5G coming up, 5G is being built on top of infrastructure that already exists. The point of presence is for the cell companies, the phone companies, and the cable companies, and the other infrastructure that's being built, the data center providers. We already have a tremendous amount of data center square foot space distributed globally. The idea that we're just going to build a whole bunch of new data centers to take on this thing is not realistic. And even if we did, that's only the edge. There's still edge infrastructure one way back. And so we need to think about this problem not as a net new, oh, I'm building a new infrastructure. We're actually building on an existing infrastructure. And so it's important to think that through, because this isn't just, oh, I'm going to go build one thing and I'm just going to make everything work. I actually have to deal with multiple operators, right? If I'm dealing with an edge infrastructure and I want to have something that spans the globe, and I'm not going to do it all in Amazon and take advantage of their footprint, or Microsoft or Google or one of the other top tier who have a pretty significant footprint, I'm going to then piece things together. Even if I'm dealing with a telco who has global presence, they actually have a lot of different operational environments, and you have to deal with that. And they're heterogeneous. And so I really don't want to read through these slides. I know you all can take that on, but we need to think through how these things are going. Right? I know one of the challenges that Mark sees in this is that while we see a lot of OpenStack moving into telco, the infrastructure that's all around it is not multi-tenant. It's not self-service. Just the opposite. It was built to not be those things. It was built to be managed by one company. The transition into that is a significant one. And if we think we're just going to drop OpenStack on top of it and it's going to, that multi-tenancy is going to be sufficient, then we're not really thinking through what edge is, right? This is where that first slide, we need to scale in. We need to think through how things actually need to operate when we're in these edge environments, when we need to manage something across 1,000 data centers. And that leads me to a really sad statement, but what I think is true. The data solutions are bad choices. Right? That doesn't mean that they can't be fixed. It doesn't mean that they're not the choices that we're going to have to make better. But either we're going to have to decide to run everything yourself, and this is what people do. This is what the retail stores that have data centers in every one of their stores, which is all of the retail. This is the fast food restaurants, right? Chick-fil-A's famous Kubernetes on Nooks. This is basically anybody who's running any infrastructure in the field. It's the farmers, it's the car companies, it's the drones. All these things are just building their own stuff. They drop it into a local data center or they put it in the back of a truck, and that's how they do edge. So that's option one. It's what we're doing today. It's hard and expensive and is not leading us to shared best practices, which is what I think open source is about to me. Or we're going to just say, oh, we're going to do it all in one vendor, which is the other easy, low-hanging choice. And just say, well, I'm going to count on, I'll keep picking on Amazon, Amazon's footprint in every geo and making that good. And while that is easy, and you get consistent APIs and things work, whichever cloud provider you do, it also creates a lot of limitations. It doesn't create the type of innovation. It doesn't create the type of control that you're here to think about, right? This is not AWS reInvent. This is the Open Infrastructure Summit. So we need to figure out how to do this in a way that is not from a single vendor. And that's why I think that what we have is enough clouds. Now I know some of you, we have some great other vendors here, and they are doing their best to compete with the behemoths. Gartner did in some ways a service, and depending on how you look at it, saying, look, there's 3 vendors, everything else is noise. Not even going to comment on that one. But the reason why I point that out is that edge is not a new cloud. And if we think about edge as a new cloud vendor, I think we're going to think about it wrong for all the reasons we've been talking about. And so the logical question you would ask at that point, because this is the dynamic that we see, isn't edge just new clouds? Isn't clouds, right? Don't we want the cloud to be an edge or the edge to be a cloud? Is there just one continuous thing? And this is a place where Mark and I love to debate and discuss. And I think it's worth thinking through this a little bit. Whoops, and I keep going back and forth. There are a lot of places where cloud is or edge will be very cloud-like. And that's good, especially if you are courting developers to build applications. This is one of my favorite points. And for the show, we interview a lot of people who are building platforms and ways that make developers' lives easier. And fundamentally, developers know how to develop things on the cloud. They're not going to build a new way to do things, right? Cloud is the way we're going to deliver and deploy applications. It sets the standard for how things need to work. Okay, and that's a good thing. Wow. All right, sorry, this is not my normal. But it's not the same. It's not the same also, right? It's much more distributed. It's going to be more multi-vendor, right? We can't just Lambda everything out. And very importantly, it's going to be location sensitive. And this is something that we actually build clouds to not care about. So if you're storing data in a cloud, one of the benefits is that there's a cloud storage infrastructure, whether it's for databases or objects or other types of items. You don't have to worry much about data or where things are, or what the relationship is between things. Right? If you're just building a Kubernetes cluster, you just build a Kubernetes cluster. That Kubernetes cluster assumes there is low latency between all of the nodes in the system. Right? That is an inherent design component. Breaking that design is effectively breaking Kubernetes, and it is going to be super hard. I know there are people trying to do it. It's going to be super hard. And when you look at edge and what edge has to be, it's a completely different thing from that perspective. And what it means is that when we build an application, and I want to be very concrete in explaining this example. When you build an application for the edge, you're building it to interact with something in close proximity. So I have an application, the demo from the keynote's a good one. I'm interacting with a camera, feeding visual input back to a human. I want low latency for that, so I need to run whatever that application is in a place where it's close, light speed close to that user, or they're going to get lag in that feed. But this could be sensors, it could be heart surgeons trying to manipulate a robot. There's applications, cars driving down streets. It's a lot of obvious applications. I think we haven't even hit the cool applications because we don't have the infrastructure for people to get creative. And what that means is that when I start an application to do that service for that user, I need to move that application and its data and its security into an environment close to that user for the duration of that user's use, right? So this could be a car driving down the street. It could be, right, intersection to intersection, having to hand off its data into other intersections. Right? It could just be a globally popular Pokemon Go where you're trying to reduce the latency of people's experience so they can interact with each other, and that needs to be within one cell tower hop. Right? It's not hard to think through these things. But to make that work, that means when you design an application, that application has to have some way to figure out, oh, I need to reinstantiate myself in this new location for the duration of that use, and then disappear. And figure out how to take its data, figure out how to remove its information. You can't build edge applications with this idea that they're going to keep tromboning back to a public cloud. It's not how an edge application is going to work. It's how my Roomba works today, and it's frustrating as hell. When it decides I can't talk to the Roomba because I've got to go through 6 layers of Amazon and back, even though the device is next door to me. Right? But that's what we do today. It's not the way this is going to grow. And so one of the obvious things that we're going to see a lot of, right, is Kubernetes. We're going to see a lot of on-metal Kubernetes. I love seeing the emphasis on this. I think bare metal is a big deal. If y'all have been tracking me, it's one of my favorite topics for many years now. And it's super hard. It's important to get it right, because if you're managing 1,000 or 10,000 data centers, BIOS changes across a fleet of machines matters a lot. Operating system patches, recovery, automating all those things, it really matters. I highlight Kubernetes here because what we see in industry is this clear trend line, even highlighted at the OpenStack Open Infrastructure keynotes, is eliminating virtualization from that equation. The reason people are doing that is not just overhead. A lot of it comes back to just simplicity. If I'm dealing with an infrastructure and I can put Kubernetes down at the bare metal level, then I've simplified that. It's a much simpler architecture. And then we're seeing a whole bunch of projects that are trying to then use Kubernetes to run OpenStack infrastructure on top of it. So you can schedule VMs or bypass that with KubeVirt and just run VMs in Kubernetes. But there is some platform at that bottom layer. Kubernetes is gaining a ton of traction. I don't know that it's the ultimate solution, but I highlight it here because it's a classic case of us squeezing out a layer that we assumed was going to be ubiquitous and doing it really quickly. And so the reason why Kubernetes becomes really important is because we do need platforms. Right? The idea that I'm going to SSH in and mess with things, or I'm going to write an inventory file and then script it, we have to have ways that create some state, maintain the life of the system, and make things keep going. And one of the things that I really like to highlight in here, and I feel like is really important from the way infrastructure works, is thinking through how we work with continuous integration, continuous deployment. This is one of those trend lines that, in my mind, DevOps sort of morphed into CI/CD, although it's not that simple. But we need to think through what a continuous deployment looks like when we get into an edge infrastructure with thousands of machines, where we're making changes to a deployment where we actually need infrastructure as code and to automate the whole thing. The whole system has to be able to be automated in a continuous integration, continuous deployment pattern. Something I've been starting to talk about as a continuously integrated data center, if you want to think about it that way, where you can literally rebuild your data center as part of that continuous deploy process. Image-based deployments, patches, moving things through, but more importantly, day two operations. And this is the thing that I think we really need to be thinking about, is the value of continuous integration, right? There's a ton of values. The business value is very powerful. A lot of it is about day two operations. The reason we do continuous integration and break things into small changes is because each time we make a change to our infrastructure, we're counting on it rolling all the way through into deployment in a controlled way. And that means thinking about blue-green deployments. It means thinking about how I'm actually going to create an immutable deployment unit instead of a configured deployment unit. Right? So if you haven't heard about immutability and being able to treat things as management units that are from an operating system all the way through to the application, like we do with containers, but even broader, all those things are challenges that are absolutely essential to win at when we look at edge. And that's a really important thing. It's not, and this is why Mark and I wanted to get on the stage. When we hear people talking about edge computing today, we don't hear them talking about CI/CD on the edge and deploying infrastructure in production in a way that makes sense at the edge. They're really busy worrying about how am I going to, manage get a Kubernetes cluster running and install something in Kubernetes. They're not thinking about the 10,000 machines problems. And so from that perspective, we're going to require a whole new piece of thinking. And one of the things I like about this slide, and it's really worth talking about here, is that it's about making people comfortable with these patterns. I don't want you to leave the room thinking Rob says, we got to redesign the way edge works. One of my lessons learned from OpenStack is that we thought we were smarter than AWS operators. And let me explain why that's, whether we are or not doesn't matter. AWS established operational patterns for interacting with cloud in a way that people understood, that a lot more people were doing than were doing OpenStack clouds. Those operational patterns got built into tools, got built into training, it got built into our collective what is a cloud psyche. Right? And I was on the board of OpenStack. I was all in. And it took me a long time to wake up and realize that we were creating friction and cognitive dissonance with our target users when we had operational differences for the users, not the operators necessarily, between them and people who were doing AWS. And I think Edge is the same lesson, which is why I want to draw it out so carefully. When we think about Edge, we need to be thinking through how would somebody approach this in the cloud, understand the problem space is different, but we have to be not creating, oh, well, this is Edge, so it's going to be a totally different tool chain or a totally different approach. The more aligned we get with a cloud approach, what some people would call cloud native, which I think is not the right term for what cloud native is, but the better we're going to do actually finding the right patterns for Edge. That doesn't mean picking the right one project. It means thinking philosophically, how are we reducing friction? And that leads me to a really important point that I can't stress enough. Operational patterns are more important than APIs. Okay, I'll give you a good example of this, cloud init. How many people know what cloud init is? I was going to have to define it either way, but it's great to get some data. Cloud init is a post-provisioning sequence that people use in cloud that basically says you take a raw machine and then you kick off post-provisioning steps that help you basically build the machine's identity or function, install software. It's the way we've emerged pretty much as an operational pattern to bring machines online in clouds, right? If you want to go in cloud, you're supporting this pattern in one way or another. And there's a whole bunch of assumptions baked into that, including this magic metadata server that all the clouds have, where you can go to a fixed address internally and say, give me information about myself, and you get it. Right? Data centers don't have that built in. That's an added service. That's an and this is going to sound funny. That one thing makes on-premises infrastructure really hard to build, because most of the tools that people want to automate with assume you have that service that understands everything that's been deployed and how it's deployed and what its IP address is and what its name is and what users have access to it. That one service makes cloud different than on-premises infrastructure or edge infrastructure, and tools assume that it's there. And so when you go to build edge infrastructure, you have to assume that things like that are in place, or the automation patterns that people are using are not going to work. The API for it doesn't really matter that much, because I can shim an API, right? I can say, oh, which is this? What cloud is this? And then build for the APIs. The thing that makes all of the multi-cloud tools hard is that they actually have to manage the different operational patterns. Not that getting a network from OpenStack is different than getting a network from Amazon. The problem is the way you use that network is different. Not that you ask for them differently. And so this is the place where we're going to hit the friction. This is the place where being a multi-vendor environment, going all the way back a couple of slides, 50% of the infrastructure is already in place. That means that you have operational patterns that you're going to have to deal with and harmonize across multiple cloud providers to make this stuff work. It's the reason why Amazon is such a threat to just own all of this infrastructure, because they already have the operational pattern. I didn't promise this was going to be a good news talk, did I? So here's where we are. We need to solve the hardest problems first. Because if you don't, then when you get to solve the hard problems, you're going to find it's very hard to change your architecture. Right? I made a comment about Kubernetes. assuming low latency built in very, very deeply in. Working across a high latency latency is really hard. And you can't just grind that back into your architecture after the fact. And so it's one of those problems where it's going to be really hard to figure out how to solve that problem. So you have to solve the hard ones. These are things that Mark and I felt were underrepresented challenges in the discussions that we're having about edge infrastructure. Cross-operator integration, right, which a lot of people would talk about hybriding. It's a really hard problem. The vendors have to help us to make that work. Zero touch from bare metal, near and dear to my heart. Oops. Near and dear to my heart. But we have to be able to do this. We can't run 1,000 sites in remote locations that require truck rolls to fix if they're going to require somebody to dial in. Even the Starling X zero touch, where somebody boosts something up and then calls into a call center and then they SSH in and then finish stuff out. That's not zero touch. That's teleoperation. Zero touch means you plug stuff in and you walk away. We have to get there. We have to be able to do this because that's how we're going to scale these sites. That's how we're going to manage the sites. There's a lot of missing pieces on managing data locality and transit in an automated way. I love talking to people about what they're doing with this because they've got ideas, but there's practical problems with this. And security is almost completely omitted. And edge is a unique security environment because it has threat postures top and bottom. Meaning, if you're in an edge infrastructure, the site that you're managing can attack you because it's somebody's home or a public network. If it's on the and you also are a data center, so you have inbound attacks in this infrastructure. So you have to operate in a completely different place. And these are places that are non-cloud use cases, right? I know for a fact all the cloud providers spend a lot of time worrying about bringing up a data center, but they bring up tens of data centers a year, and then they run them to huge scale. They don't bring up 10,000 data centers a year, and that's the scale of the problem that we're talking about. So at the end of the day, we have to figure out how to run the infrastructures we have and not touch them. Cool. Thank you. And I did save time for questions if I've got some. Or rants.
Rob, excellent, thought-provoking on the edge. I think it's counterintuitive, but great presentation. I'd like to hear from you what you are doing in your area to make this happen.
I'm happy to do that. So RackN is focused on bare metal automation, and we actually have rethought the problem because what we looked at from a bare metal perspective is it's not about provisioning, it's actually about integration. And so what we think of, and this is generally applicable for edge and any data center infrastructure, is that it's not can I install an operating system, which is where a lot of people think bare metal. It's actually, can I integrate that into the operating environment that it's a part of? And that's so that we rethink that. That's done out of an open source project called Digital Rebar that I would encourage people to take a look at. That actually, it's about provisioning, but it's also about infrastructure as code. It's about how you do composable management and automation and things like that. It's a totally different way to think about the problem.
So where do you see, just add on to this, we have zero-touch provisioning and day 2 operations in the HC, and we have here on the open source side, which you are trying to put together. Where do they meet together, or what's the gap, and how do you see moving forward?
To me, to give you a short answer, I think the gap is composability. I think that we do not do the right job as an industry figuring out how to make things play well together. We wire things together way more than we want to admit we do. And that ends up being a really significant problem. And it's more of a problem, I'll be specific, it's more of a problem, it's even more of a problem at bare metal. Because when you get bare metal, every server is a snowflake, right? You have to deal with heterogeneity at the BIOS level, at the drive level, at the NIC level, at the naming convention level, at the way switches are wired level. And those differences are not wrong differences. This to me is if you want to take it to a philosophical level, the biggest problem we have is that when we write code or run a data center, we have a tendency to think that we're doing it the right way. And we all are doing it the right way, and we're all doing it differently. And that will not change. And so as soon as you come in and say, we have to run it this way, we have to have out-of-band management to boot a machine, right? Or we have to have one of these specific protocols to boot a machine, you've broken most people. And so you actually have to build the software, you have to build all these infrastructures and from the bottom up in ways that allow pluggability. One of the things that I think made Kubernetes super powerful is that they actually embrace extensibility into the APIs. When OpenStack was having the conversation about API extensibility, we were very nervous about it, and we backed off on it. Kubernetes, and it could hurt them in the end, but they've been really good about saying, oh, I can add a whole new kubectl approach. Like, so if you look at the kubevert stuff, you can do machine, VM control, whatever, and it's the Kubernetes APIs bringing up a VM. That was never in the Kubernetes plan, but they extended the API to do it. We need to be thinking like that up and down the stack.
So to end, last question. How do you see the cluster API with bare metal in this context?
We are very excited about it. We did a demo about 6 months ago, driving the cluster API pieces. And this is actually a really good example of my operational assumptions. The cluster APIs assume that you can inject a cloud init file to bring up systems because their targets are all clouds. So if you want to do bare metal with the cluster management, you have to be able to handle cloud init. So I'm really excited to see it because I like when Kubernetes says this is how we want to operate things. And at the same time, I look at it and recognize that for it to work for bare metal, you have to have a platform that provides cloud capabilities, provision, deprovision, start-stop control, image-based deployments, things like that, cloud init, load balance, all that stuff has to be done somewhere. And so the number of assumptions that are baked into tools like that are very, very high because they're targeting clouds, right?
Thank you, and excellent presentation.
Thank you.
Very thought-provoking, and hopefully we'll see you again and again.
Thank you. Appreciate it. Other questions? Yeah.
Good morning. Thank you for the talk. It will be only one quick question. Do you know about any related work for these operational patterns that we, part of the OpenStack community, can actually check, contribute, improve?
Operational, what do you mean by an operational fork?
The operational patterns that you were speaking about before.
Yeah, so this is one of those places where something like Terraform, which has its own operational challenges, talk about that on Friday, not here, but you have to be very embracing to how other tools are going to use your platform, and then figure out what they're trying to accomplish to make that happen. So the answer is sort of backwards. It's not to say, hey, I want to fork in these capabilities. What we really missed our opportunity to do was really embrace a lot of API clients that were trying to consume things, and when they would bump into a wall, say, why are you trying to do it that way? How do we implement it? And I'll say something super controversial. I think Heat being a core project was a mistake that undermined undermined that capability, because what we would do is turn to people and say, well, no, we don't do it the way Terraform does it. Just use heat. Heat's the OpenStack approved way to do it. And we missed this operational opportunity to say, well, it doesn't matter how OpenStack does it. You have to do it in ways that are operably similar to other people. And that's actually, so when we build things at RackN, that's what we're doing. We're not saying you're wrong to ask us for this. Why are you doing this? Let me see how we can support that operational pattern, even if we don't think it's the best pattern.
Thank you.
Cool. Thank you very much. I am out of time, and I see people coming in for the next room. I'm happy to take questions, and we do have that invitation if you want to rant at us and tell us we're wrong.